हेलो स्टूडेंट्स, आइए आज ये जेई एडवांस 2018 का पेपर वन का हम सॉल्व करते हैं मैथमेटिक्स का। तो क्वेश्चन इज कि फॉर एवरी ट्वाइस डिफरेंशिएबल फंक्शन f real to minus 2 closed interval with f 0 whole square plus f dash 0 whole square is equal to 85, which of the following statements is r true? Option A is there exists r comma s belong to real where r is less than s such that f is 1 1 on the open interval r comma s. Then option is that there exists x naught belong to minus 4 comma 0 open interval such that f dash of x naught modulus is less than equal to 1. The third option is limit x tends to infinity f of x equal 1, and the fourth option says that there exists a alpha belonging to the open interval minus 4 comma 4 such that f of alpha plus f double dash alpha is equal to 0, and at the same time f dash alpha is not equal to 0. So there is no mention यहाँ पर कुछ भी क्वेश्चन में कौन सा फंक्शन है ये मेंशन नहीं है. इट इज जस्ट सेइंग दैट इट कैन बी एनी फंक्शन which is twice differentiable. There are certain constraints of course given to us. those constraints को एक बार हम लोग देख लेते हैं. एक तो है कि फंक्शन जो है उसका रेंज -2 से 2 के बीच में है, राइट. So it's taking a value from the x can be anywhere on the real number line, but the value of the range has to be between -2 and 2. Another thing to note here is that there is a boundary condition given to us at x equal to 0, which tells f of 0 whole square plus f dash of 0 whole square is coming out to be 85. This is another kind of constraint given on us, and it is saying that the function is twice differentiable. So इसका मतलब है कि first of all the function itself is continuous, right? The second thing is f dash also must be continuous, right? Because again I can differentiate it, and then f double dash does exist, right? F double dash exists, and this is how we can say that function is double differentiable. So these are the only constraints given to us. There is no mention of a specific function as such, but obviously we can understand that there will exist multiple such functions because the word itself says for every, right? So it means that there can be multiple such functions. Now coming to the point that we can solve this using two methods. One is we can assume a function which satisfies these constraints, right? And then we can, whatever the function that we get, we can test that function on A, B, C, D options, right? And try to see like whether that is satisfying the options or not. That is one way. Another way could be that we assume the function to be a generic function, just constrained by these constraints that are given in this equation, and then try to see that whether under those constraints the function will obey or satisfy any of these A, B, C, D options. So there are two ways. One is by assuming a function, another way is going on a generic basis. So now let's see in both these ways. So let's see option A first, which is talking about that there exists r comma s belong to r where r is less than s and f is 1 to 1 on the open interval r comma s, right? So पहला मेथड से जहाँ की हम लोग कोई फंक्शन अज्यूम कर सकते हैं. सो यहाँ पर मेरे माइंड में sin x function aa raha hai. Now obviously there can be multiple functions like sine, cos, and many other functions which can satisfy, but looking at this range which is -2 to 2, right? The easiest function that I can think of is a sine function, right? Because it obviously the range is -1 to 1, and if I multiply it with 2 I will get the range of -2 to 2. So I can assume the function to be, let's say f of x is equal to 2 times of sine. Now, another important thing to understand is that there is only one boundary condition given to us. So I can have just one variable to solve it, right? So I cannot say something like ax plus b, right? Because then I will have a and b both to solve. So there, but I am given just one constraint, right? So I cannot afford to have two variables a and b. So therefore, the only option left with us is to assume a of x, right? For solving because of the constraint that is given to us. So let the function be of this form 2 sine ax. Now we know the constraint, so let's apply that constraint to find the value of a. So f of 0 will definitely become 0, as we can see. F dash at 0 will become equal to 2a sine of ax at x equal to 0, right? So this will become nothing but 4a. So f dash 0 is 0 plus f dash 0 whole square, which means it will become, sorry, this is 2a, so it will become basically 4a square. 2a square is 4a square, will be equal to 85, and that means a will be equal to root under 85 by 2. Therefore the function that I got is 2 sine root under 85 by 2 into x. This is one of the functions which is satisfying all my constraints, right? Obviously, you can see with the value of 2 put over here, the range of this function will go in this minus 2 to 2 closed interval. So all the constraints that are given to us, this particular function that we have assumed is going to satisfy that. Now, we already know a sine function graph, if we have to draw, the graph will be something like this. Just I'm drawing for one cycle, obviously it's going to repeat. So here the value will be plus 2 and here the value will be minus 2. So something of this sort, right? And now you can see that if I pick any value r and s, let's say I'm picking a value r over here, x equal to r, and then I'm picking a value s over here, right? So in between r and s, you can see that the function is an increasing function, right? And therefore it must be one on one, which means that for any value of x, I will get a unique value of f of x, right? So in between this, you can see that at any value of x, I will get a unique value of, sorry, at any value of x, I will get a unique value of f of x, which means that it's a one-on-one function. So this was based on the uh, assumed function, and that is we are seeing that when I apply test it on the option A, it does make sense. So therefore option A is correct. But also let's try to see this with the help of a generic function. In that case, the only possibility where option A will become wrong is the fact that the generic function is a constant function. Why I say that is because if suppose f of x is not a constant function, then in that case, if I want to draw the graph of a generic function f of x lying in between minus 2 and 2, so in that case, if I pick x equal to r somewhere and x equal to s somewhere, the function has to be either increasing or it has to be decreasing, right? Because and f dash x is also continuous, right? So the function has to be either increasing or decreasing in the interval r comma s. Now if the function is either increasing or decreasing, then in that case, if I pick up any value in between r and s, so let's say I pick a value a over here and another value b, you can very well see that it is going to give you a unique value of function of a and function of b, right? In both these cases, I mean whether it is decreasing or increasing case, both of these cases you will get a unique value of f of a and f of b, with lying between where a and b lies between r and s. So therefore that it is therefore it will be one to one in the open interval r comma s. The only possibility where this option will fail, right, is the fact when f of x becomes a constant function, right? If suppose my function is constant somewhere over here, obviously it has to be less than 2, it has to lie between minus 2 and 2. So let's say this is a constant function. Now in this case, if suppose my r is here, my s is here, in between, if I take let's say a and a value b of x, then the value of f of a and f of b will come the same, right? Both the value will come the same. And then in that case, it will not remain a one-to-one function, right? Because multiple values of x are pointing to the same value of f of x, right? So in that case, it will not remain injective. So the only possibility is when of discarding option A is or option A is not possible if f of x is a constant function. Now let's check whether f of x is a constant function is possible in itself or not. So if I assume that f of x, let's say, is a constant function and apply this constraint f of 0, so f of 0 will become constant c, so c square plus f dash 0 will become equal to 0 because fx is a constant function, f dash will become 0, f dash 0 will become 0, so 0 square is equal to 85, which means c is equal to root 85. That is the only possibility that is left with us. In that case, f of x is going to be equal to root under 85. But we are given that the range of this f function is between minus 2 to 2 closed interval, and root under 85 is obviously out of this bound, right? So therefore the possibility that fx is a constant function can be discarded. Fx cannot be a constant function. Now if the fx is not a constant function, this cannot happen, right? And therefore the only possibility that is left with us is this. And in this particular case, we are already seeing that if I take a and b as two separate values of x, there will exist f of a uniquely and f of b uniquely, because the function between r and s is going to be a continuous function, a increasing or a decreasing function, right? In both these cases, the option a will hold good. So from a generic function perspective also, provided function x is not a constant, which obviously is the case that it is not a constant function, my option a still holds good. So therefore, we have seen that for both a assumed function perspective and a generic function perspective, A option definitely is a correct option. Now let's look at the option B, where we want to check that there exists a point between -4 comma 0 open interval where f dash at x0 modulus is becoming less than equal to 1. So in order to solve this, let's use Lagrange's mean value theorem. So LMVT, right? LMVT. Now, what does LMVT says? By the way, I have made a video on LMVT and Rolle's theorem. You can go and watch in the playlist. But a quick recap of what LMVT is. So LMVT basically says that if there is a function f of x between the interval a and b, so there is a function between a and b, then there must exist. Now this the basic rules behind is that f of x must be a continuous function between a and b, closed interval a and b. It must be a differentiable function within open interval a and b, right? So why we say open interval? Because the function is continuous between a and b, right? We don't know what is happening on the left hand side of a, what is happening on the right hand side of b. So we cannot talk about the differentiability in the at the point a and b itself, because we know only the from one side we are aware, right, what is happening at a or b. So therefore I can talk of that function x is continuous between closed interval a to b, and there is and the different and it is differentiable in the open interval a to b, right? So if that is the situation, then in that case there must exist a point c within a and b, within A and B or between A and B, such that f dash at C, which means the differential of this function at that point C, will be equal to f of B minus f of A by B minus A. Now on the right hand side, what you see, f of B minus f of A by B minus A, it is nothing but the average slope of this function between A and B. So if I draw a straight line joining f of A and f of B, this is the straight line. So the slope of this line, pardon me, it's not looking like a straight line, but yeah, it's a straight line that I've drawn. So this straight line slope is nothing but f of b minus f of a by b minus a. Now that there must exist a point c whose slope, the slope will be equal to this average slope, right? So you can see that there is a point c over here whose, if I draw a line or I draw the slope of at C, the line will be almost parallel to this average line, right? So therefore, we can say that the slope of these two lines will be same, and that is what Lagrange's mean value theorem actually says, right? So we will apply this LMVT over here to check option B. So in this case, let's do it on a generic function first. So imagine that our function is between -4 and 0 open interval. Obviously, we know that f of x is uh, is going to be differentiable. So I will say f of, there must exist f dash of x naught, in x naught lies between -4 and 0, such that its value is f of 0 minus f of -4 by 0 minus of -4, right? Basically from the LMVT. And this means it is equal to f of 0 minus f of -4 divided by 4. Now if I take the modulus on both the sides, right? If I take the modulus on both the sides, the value of mod of f dash x naught will be equal to mod of f of 0 minus f of -4 upon 4. Now let's see what is the value that is coming for the numerator. F of 0 can take the maximum value of 2. F of -2 can take the f of -4 can take the maximum value of -2. In that case, the maximum value of the numerator will come equal to 2 minus of -2 by 4, right? This is the maximum value I can get, which is equal to 1. if I look at the minimum value, then it will be, let's say, f of 0 takes the value -2, f of -4 takes the value 2. So in that case, it will be -2 -2 by 4, which means the value is coming out to be minus of 1, right? So in this case, the the value of mod of f of 0 minus f of -4, right, divided by 4 is lying between 1, is lying, the value of this is going to lie less than equal to 1, right? Because it is a modulus, so I'm saying just less than equal to 1. So therefore modulus of f dash x naught is less than equal to 1 is certainly looking to be true from the perspective of a generic function. Now let's also look at it from the perspective of the assumed function that we had. So in that case, we had assumed that f of x is equal to 2 times sine of root 85 by 2 of x. Therefore, f dash x will be equal to root 85 cos of root 85 by 2 upon into x, right? So this is my f dash x. If I draw the function, right, the cos function will look something like this, right? Something like this. Now here, this is the value of theta. Theta is nothing but root under 85 by 2 times of x. So at x equal to 0, theta will be 0 and the value will be root under 85. The value of the f dash x will be root under 85. Now if I want to make f dash x modulus less than equal to 1, which means that f dash x should be less than equal to 1 and greater than equal to -1, right? This is what I want. Now in this situation, if my value is like that, then obviously obviously there will be a point, let's say 1 over here and -1 over here, right, on the y-axis. So you can see that if I go and check it, 0 is coming over here. So around this point, right, around this point, and what is this point? This point is theta is equal to pi by minus pi by 2, right? This theta is minus pi by 2. Around minus pi by 2, around minus pi by 2, theta equal to minus pi by 2, theta equal to minus pi by 2, I can say that the function value can indeed be, or the function dash x value can indeed be between -1 and 1, right? Because it's a continuous function, it's decreasing over here, it's starting from root 85 at theta equals 0. So definitely somewhere it will come and hit the value of 1. And again it is going down, so it will hit a value of -1 also. So around this minus pi by 2, I can say that there is a value that will lie in, the value of f dash x will lie between -1 and 1. Now that means theta is equal to minus pi by 2, which means root under 85 by 2x is equal to minus pi by 2, which means there will be existing around around x around x equal to minus pi by root 85, right? Minus pi by root 85. So around minus pi by root 85, x equal to minus pi by root 85, I can say that the value of f dash x will lie between -1 to 1. Now you see that root minus of root pi by 85 is definitely going to be lying within -4 comma 0, right? It is within that interval. So therefore, for this particular function which we have assumed, the value of f dash x will be in between -1 to 1, or the modulus of f dash x will be less than equal to 1 in a value of x around minus pi by root 85, which is within 0 comma -4 interval, right? So therefore the option B is looking correct from this perspective as well. So from we saw from both the perspectives, generic function as well as this assumed function, and both of them is saying that option B seems to be correct. So option B is also correct. Now let's move on to the option C, where we are wanting to find out that limit as x tends to infinity, f of x is equal to 1. So let's start with our assumed function, which was f of x equal to 2 times sine root 85 by 2 x, right? Now if I make the limit of x tend to infinity, limit as x tend to infinity, definitely we see that this function does not exist. The limit of f of x as x tends to infinity does not exist. Does not exist. So therefore, from a function that we have assumed, which was satisfying all this equation so far, or the constraint so far, we are seeing that this option C does not hold good. So that means option C must be wrong. So that is from a assumed function perspective. Let's also look at from a general function perspective. As we already know that that this particular function is is a continuous function. The f dash x is also continuous. So the function is either increasing or decreasing, right? So if I want to draw the graph of any such function, let's say I want to reach to x equal to infinity, and let's say I try to make intervals, let's say 0 to a, to b, to c, to d, and so on, and then I'm trying to reach at infinity. So in between 0 to a, right, we already saw that the function could be either increasing or decreasing, right? So let's say it is increasing in 0 to a. By the way, all this has to happen between plus 2 and minus 2, right? All this ups and downs that we will see in the equation has to happen between 2 and minus 2, because that is the range that it is following, right? So it is, let's say, increasing over here, then it can be further increasing, right? It can then go come down, it can further go down. So by the time it reaches, after doing all this, it reaches infinity, it can go up to, let's say, this value, right? It has gone to that value. But there is no other constraint that is given to us. So I am just knowing that the function within an interval is either increasing or decreasing. It is continuous, right? So I can make such function in multiple ways, right? It can be, let's say, now decreasing between 0 to a, then again increasing, then again decreasing, right? And I can go again, and let's say at infinity I reach to some other value. So the only thing we know is about that the function is going up and down in a given interval. What is the value that it will finally land to when it is reaching to x equal infinity is something which is not given, or is not known from the constraints that are given in this equation. So it can take any value, either it can land here or it can land here, or I could have drawn any other function, right, which could have gone and landed, let's say, here. So all that is possible. So at x equal to infinity, I cannot guarantee, based on the constraints that are given, I cannot guarantee that it will take a unique value. So therefore, limit as x tends to infinity of function of x will not exist, right? Does not exist. So therefore this option is again wrong from the perspective of a, if I think of it from a generic function perspective as well. Now let's look at option D now. So for option D, let's say that now I'm looking from a perspective of a generic function. So let's assume that there is a function g of x which is given as f of x whole square plus f dash of x whole square. This is my g of x. That means g dash x will become equal to 2f 2f of x into f dash x plus 2 times of f dash x into f double dash x, right? So therefore I can take out 2 f dash x common, 2 f dash x, and then I will have f of x plus f double dash x. Why I did so? In order to get this form, right? F of alpha plus f double dash alpha. So here we can see that I want to make, if I take alpha, then this is what it is asking, that g dash of alpha will be equal to 2f dash alpha multiplied by f of alpha plus f double dash alpha, right? And it is saying that this value has to be 0, and f dash 0 does not need to be 0. So it is not equal to 0. One part is not equal to 0, the another part is equal to 0. So that means the entire g dash alpha is equal to 0, right? That is what, and we have to prove that g dash alpha has to be 0, but f dash alpha is not equal to 0, right? This is not equal to 0. This part is something which is equal to 0, and this is happening in the interval minus 4 comma 4, right? For the alpha is belonging in that interval. So now let's see that we had we had seen already that if I assume this function, if I took this function as g of x equal f of x whole square plus f dash x whole square, then the gx value can be taking the maximum value of gx at any x, right? At any x will obviously be maximum. It can go up to 4 plus f dash x whole square, right? This is the maximum value of gx, right? So it will be always less than or equal to g at any value of x on the real number line will be less than or equal to 4 plus f dash x whole square. Why 4? Because f dash x, fx is lying between minus 2 to 2, so the maximum value of fx whole square will be equal to 4. So therefore this is what I will get. Now if I take a specifically between minus 4 and 4, I have already seen that between minus 4 and 4, minus 4 and 0 from the option B, I am seeing that f dash x 0. So there will be a point between minus 4 and 0. Let's say that point is x1. So there will be a point for which f of x1 must be less than equal to 1. A modulus of f dash of x1 must be less than equal to 1. This is what we know. The same thing I think we can do for between 0 to 4 also. If I, let's say, apply the Lmvt for the interval 0 comma 4, I can say that there will exist a point, let's say f dash at x2. X2 will exist such that f dash x2 will be equal to f of 4 minus f of 0 by 4 minus 0. Again the value of this will be lying in between. This will be less than or equal to 1 and greater than or equal to minus 1, which means modulus of f dash of x2 will be less than equal to 1 again. So there are 2 points between minus 4. So if suppose my minus 4 is here, plus 4 is here, there are 2 points, imagine x1 and x2, in these intervals, in this interval of minus 4 to 4, where the value of f dash x1 is less than equal to 1 and f dash x2 is less than equal to 1. So that means their square is also less than equal to 1. So it means that g of x will be less than g at x1, right? There will be a point x1 where the value cannot go beyond 4 plus 1, because the f dash x cannot go beyond 1, so it will not go below beyond 4 plus 1, which means it will be less than equal to 5. Same thing for the point x2 also, right? So there will be a point g of x2 where which cannot go beyond 5. So let's say here is my 5. So f of that, so g of x1 will be less than 5, right? Let's say it's here. Same way it will be somewhere here. It cannot go beyond 5. It will lie between less than 5, right? So that is what it is telling as of now. But also we know that g of 0, if I take g of 0 is nothing but f of 0 whole square plus f dash 0 whole square, which is the boundary condition given to us, equal to 85. So g of 0 will be somewhere here, which is 85. Now what does this suggest? That the function has to pass through these points. The g of x function has to pass through this point, and also this point, right? All these 3 points. We know that these 2 points are below 5, right? These 2 points are below 5, but this point is 85, right? At 0 it is 85. So therefore you can see, and also the fact that fx is a continuous function, right? Obviously this function has to go up and then come down, right? That is the only possibility left, right? So in that case, now there can be 3 ways, right? It can be directly going like this, hitting the maximum at 85 itself and then returning back, right? Or there could be a possibility that it goes even higher, right? Even higher, and then goes to 85 and then returns back to it, to this point, right? So anything is possible, right? either it can Either it can go to greater than 85 in the interval x1 comma 0, or it can take the value greater than 85 in the interval 0 comma x2. Anything is possible, right? It can even take like this. It can even do something like this, right? So all this is possible. So the point is that g of x, right, in this interval x1 x2, in the interval x1 x2, the value of g of x is less than is greater than or equal to 85, right? That is what we are seeing. There must be a value in between x1 and x2. Let's call that value as alpha, right? So that must be greater than equal to 85. Now if that is the case, then we have two things left here. Let's see here. I don't have space, but let's see here. So we are saying that at alpha, g of alpha must be greater than equal to 85, and at the same time g dash alpha has to be equal to 0, because obviously that is the point of maxima, right, for the g function. So both these things need to be satisfied. Now if I make g dash alpha is equal to 0, there are two options with me. I can either make f dash alpha is equal to 0 to make g dash alpha 0, or I can make f of alpha plus f dash alpha equal to 0 to make g dash alpha 0. Let's assume that we are trying to make f dash alpha equal to 0 in the first case. Now if I try to make f dash alpha is equal to 0, from this equation, or the boundary condition that we had, we will see that g of alpha is equal to f of alpha whole square plus f dash alpha whole square. I have made f dash alpha whole square equal to 0. So that means g of alpha must be equal to f of alpha whole square. And that means that the value of f of alpha whole square cannot go beyond 4. Right? So g of alpha will not be able to go above 4. So g of alpha will remain less than equal to 4 in that case, if I try to make f dash alpha equal to 0. So that means my this option of G alpha has to be greater than 85, greater than equal to 85, is not getting satisfied, right? If I'm trying to make G dash alpha by making F dash alpha equal to 0, right? So in that case, G dash alpha is has to remain less than equal to 4, but we are given that it has to be greater than equal to 85, which is not possible, which is not making sense. So the only possibility left with us is to make f alpha plus f dash alpha equal to 0, right? So obviously there will be existing a point, and that point exists. Why that point exists is what we are seeing over here, because there is a point, a minimum point tied below 5 at x1, below 5 at x2, and then there is a point in between which is 85. So the function has to go up and come down. So there must be a point where it is achieving a local maxima or minima, right? We are talking about g of x, right? G of x, it is achieving a local maxima or minima. So that maxima or minima can be 85 or greater than equal to 85. And at the slope over there, which means g dash alpha, will be equal to 0. So therefore, these two conditions will be holding correct. But in order to make g dash alpha equal to 0, if I go and try to make f dash alpha 0, then I start getting that g of alpha cannot go beyond 4, right, which violates my first condition. So therefore the only possibility left is f of alpha plus f dash alpha, f double dash alpha is equal to 0, and that is what the question is asking, that there exists alpha in the range minus 4 to 4 such that f alpha plus f double dash alpha has to be 0. So that will make my g dash alpha 0, but f dash alpha is not equal to 0, which is fine, right? Because if my f alpha plus f double dash alpha becomes 0, still I will get g dash alpha is equal to 0, and still I can have g of alpha greater than equal to 85. Both conditions can be met, right? So therefore, option D also is correct option from the general function perspective. Now let's look at the same thing from a specific function that we had picked up, and then try to see that whether on that specific function this option D is being applied or not. So let's start with our assumed function again, f of x equal to 2 sine root 85 by 2 times x. This was our function. Now f of alpha will become equal to 2 sine root 85 by 2 alpha, and f double dash at alpha will become equal to uh, 85 by 2 minus sign will come, and sine of root 85 by 2 of alpha. This is what f double dash alpha will become. If I add this 2, it will be 2 minus 85 by 2 into sine of root 85 by 2 times alpha is equal to 0. Now if this condition is happening, it means my alpha is Alpha can take the value 0, it can take the value uh, pi, it can take the value of root 85 by 2 into alpha will be either 0. So root 85 by 2 times alpha can take the value 0, or it can take the value pi, it can take the value 2 pi, and so on, right? So alpha can take the value 0, it can take the value 2 pi by root 85, or 4 pi by root 85, and so on, till the point, or even on the negative side also the same things, right? So it can be plus minus 0, plus minus 2 pi by root 85, plus minus 4 pi by root 85, and so on, till the point we get alpha between minus 4 to 4 interval. So there are multiple points at which I can get the value uh, uh, there are multiple alphas, right, where I can get the value f of alpha plus f double dash alpha is equal to 0, and all those points are over here. Now it says that at that particular value where we are seeing f of alpha plus f double dash alpha is equal to 0, my f dash alpha need not be 0, right? F dash alpha has got to be equal to 0. Now what is my f dash alpha? F dash alpha is nothing but uh, root 85 cos of root 85 by 2 into alpha, right? Now, in between these intervals, right, wherever alpha is taking these values for which my sine is becoming 0, right? Obviously, we know that cos is not going to become 0. So for all these values, let's test it on one of the values, like let's pick up 2 pi by root 85. So it will become root under 85 into cos of root 85 by 2 into 2 pi by root 85, right? So that means this will become cos of pi, and cos of pi you already know it is minus 1, so it will become minus of root 85. So obviously it's not equal to 0. So therefore we are seeing that there will be existing alphas, right, between minus 4 to 4, where f alpha plus f double dash alpha, which is giving this sign expression to us, is becoming 0, but at the same time f dash alpha, which is this cos expression that we are getting, will not be equal to 0. So therefore for this particular function also, we are seeing that when we are testing on the option D, it does satisfy option D as well. So therefore option D makes sense from the perspective of the assumed function also. So this is also correct. So overall we are seeing that option A, option B, and option D are making sense, and they are the correct options for this question. So hope you enjoyed this video. We got a very detailed solution of this problem. Why I wanted to go in detail is because just by looking at the steps, we don't kind of get into the depth of the understanding. So I wanted to go in little depth and try to explain each step and the logic behind why it's happening or not happening. So hope you enjoyed this video in detail. I will be coming up with more such JEE advanced problems in more detail, more uh, uh, in-depth understanding. So please like, subscribe to our channel. Uh, please share with your friends whoever need this kind of content, be it in class 12, be they in class 12 or in preparing for JEE. So please share with them. Please like this video, and keep enjoying, keep learning. Have a great day, and all the best. Thank you.